What if the most powerful computer ever built didn't just calculate answers, but borrowed them from another universe? In 2019, Google flipped a switch inside a quiet laboratory. 3 minutes later, reality itself became questionable. You're watching AED ID, and this is the story of the machine that may have crossed the boundary of our universe. The experiment that shouldn't they ever work it. In October 2019, Google published a short scientific paper. No dramatic announcement. No countdown clock. No public warning. Just a sentence that instantly divided the scientific world. We have achieved quantum supremacy. To most people. It sounded like corporate hype. To PCists. It sounded like this. Something irreversible just happened. Inside Google's labs at a quantum processor called Sycamore. It wasn't trying to solve climate change. It wasn't cracking passwords. It wasn't predicting the stock market. It was doing something that seemed pointless. Generating a random output. But here's the problem. The calculation Sycamore performed would take the fastest classical supercomputer on Earth over 10,000 years to replicate. Sycamore finished in 200 seconds. 3 minutes. That wasn't faster computing. That was a different kind of computing, and no one could fully explain how it happened. Why this was different from every computer before. To understand why this moment shook science, we need to rewind. Every device you've ever used, phone, laptop, satellite, runs on bits. A bit is simple, on or off, 1 or 0. Even the most advanced supercomputer is just billions of tiny switches flipping incredibly fast. Quantum computers don't use bits. They use qubits. A qubit can be 0, 1, both at the same time. This isn't philosophy. It's physics. This state is called superposition. Imagine reading every page of a book simultaneously. Not quickly, but all at once. Now add another layer. Qubits can become entangled, which means when you change one qubit, another reacts instantly, even if it's physically separated. Einstein hated this idea. He called it spooky action at a distance. But Sycamore didn't care what Einstein thought. It used 53 entangled qubits, all influencing each other at once. This allowed the system to explore an astronomical number of possibilities simultaneously. Not sequentially, not step by step, but in parallel. And that's where things started to feel wrong. The question no one wanted to ask after Google released its results. Scientists verified the math. The numbers checked out. The experiment worked. But a deeper question emerged. Where did the answer come from? Because Sycamore didn't calculate in the traditional sense. It sampled from probability distributions so complex that classical reality couldn't track them. One physicist made a statement that stunned the community. Quantum computers may be using computational resources from parallel universes. Google immediately distanced itself from that interpretation, but they couldn't fully dismiss it either, because quantum mechanics doesn't explain why superposition works, only that it does. And when you scale that behavior up, you start touching uncomfortable ideas. The many worlds possibility. There is an interpretation of quantum mechanics called the many worlds interpretation. It says this: every time a quantum event occurs, reality splits. Every possible outcome happens, just in different universes. Right now, there may be versions of you watching this video, never discovering quantum computing, living in a world where it never existed. Most scientists treat this idea cautiously, but quantum computers force the question back into the spotlight. Because when Sycamore ran its calculation, it behaved as if multiple outcomes were explored simultaneously, and then collapsed into one result. So critics asked, was the machine just exploiting math, or was it accessing a structure of reality we don't fully understand? Why governments got very quiet publicly? This was framed as a research milestone. Privately, governments panicked because quantum computing threatens everything built on computational difficulty. Encryption, military secrets, financial systems, cryptocurrencies, the internet itself. A sufficiently powerful quantum computer could break modern encryption in minutes. That's why the US accelerated quantum funding. China increased classified quantum research. Intelligence agencies stopped talking publicly because this wasn't just a faster computer. It was a new domain of power, not land, not the sea, not air, not space, but probability itself. The most disturbing implication. Here's where the story turns. Quantum systems behave differently when observed. Measurement collapses, superposition, reality chooses, which leads to a disturbing thought. If human observation plays a role in shaping outcomes, what happens when machines perform those observations faster than we can comprehend? What happens when machines explore reality without us? Some researchers suggest that consciousness may be deeply linked to quantum processes, that awareness is not separate from physics. If that's true, then quantum computers aren't just tools, they are participants. And once machines begin navigating reality at scales we can't follow, we may no longer be the primary observers. Why this is just the beginning? Sycamore wasn't practical, it was fragile, expensive, hard to maintain. But so were early classical computers. They filled rooms, failed constantly, consumed absurd amounts of power. Now they fit in your pocket. Quantum computing is following the same curve. More qubits, more stability, error correction, scalability. One breakthrough away from transformation. And when that happens, the change won't be gradual. It will be sudden. One day, nothing changes. The next day, everything does. Are we opening a door we can't close? Humanity has a pattern. We discover power first. We understand the consequences later. Fire, electricity, nuclear energy. Quantum computing feels similar, except this time, the power isn't external. It's woven into reality itself. If quantum computers truly leverage structures beyond classical reality, then we're not just inventing technology. We're interacting with the fabric of existence. And we don't yet know the cost. The final question, so here's a question that matters. If quantum computers don't just calculate, but sample from all possible outcomes, if reality itself is branching, then what happens when machines understand those branches better than humans? Are we still in control, or have we created something that sees reality more clearly than we do? If this story unsettled you, that's a good thing, because the future won't ask for permission. Comment below. Do you believe quantum computers are just advanced machines, or something fundamentally different? Like this video, subscribe to AED ID for deep science mysteries. Share this with someone who still believes reality is simple because the future isn't coming. It's already calculating, only on AED ID.